we're going to go through the answers to this second law and terminal velocity questions. So the figure below shows a horizontal force is acting on a car. You've got 800 forwards and 800 backwards. Which one of the following statements describes the motion of the car? Well, if the forces are balanced, it's either stationary or moving with a constant velocity. Okay, now this has got a force forward, so it must be moving, so it will be moving with a constant speed. During part of the journey, the car is driven at a constant speed for 5 minutes. Which one of the equations links distance travelled, speed and time? So distance is speed times time, which is number 2. During a different part of the journey, the car accelerates from 9 to 18 meters per second. So U is 9, V is 18, initial velocity, final velocity, and the time is 6. It says calculate the acceleration. So that's change in velocity over time. So that's V minus U, final velocity, take away initial velocity divided by time. So 18 is our final velocity, take away our initial velocity, which is 9, divided by 6. That gives us an answer of 1.5 meters per second squared. Okay? That's worth 2 marks, I think. So you get a mark for putting the numbers in and a mark for the answer. Then it says, which equation links acceleration, mass and resultant force? So resultant force is mass times acceleration, so it's the second one. It tells you that the mass of the car is 1120 and the mass of the driver is 80, so our total mass is 1200. We know our acceleration is 1.5 from the previous question, so it wants us to calculate the resultant force. Use F equals MA, substitute our numbers in, 1200 times 1.5, which gives us an answer of 1800 newtons. And it says calculate the distance the car is travelled while it's accelerating. Use the equation from the physics equation sheet. So we're going to use V squared equals U squared plus 2AS. So let's substitute in the values that we know. We know that V was 18. We know that U was 9. And we know that A is 1.5. So let's substitute those values in. 18 squared equals 9 squared plus 2 times 1.5 times S. Let's do the maths that we know. So we know 18 squared is equal to 324. We know 9 squared is equal to 81. And we've got 2 times 1.5, which is 3S. Right, let's get rid of the things that we need to get rid of. So we need to get rid of this plus 8 here. So we'll take it to the other side. So 324 minus 8 equals 3S. Now we need to get rid of the 3. So we divide both sides by 3. So those cancel. And our answer is going to be 324 minus 8 divided by 3. Okay, 324 minus 8 divided by 3, which gives me an answer of the wrong answer. 1 second. Did you spot my mistake? 9 squared is 81. Did the maths right, put 81 in by accident, put 8 instead of 81. Yes, that gives us an answer, final answer of 81 as well. Yeah, 81 meters. Okay, so you get a mark for substituting the values into this, you get a mark for doing this rearrangement, and then a mark for the answer. Then it says, a driver sees a fallen tree lying across the road ahead and makes an emergency stop. The braking distance of the car depends on the speed of the car. For the same braking distance, explain what happens to the braking distance of the car if it doubles. Basically, braking distance depends on your kinetic energy. So, if we remember, it says here you should refer to kinetic energy in your answer. So, first thing to do is write down the kinetic energy equation. 0.5 mv squared, okay? So, if you double the velocity, the kinetic energy increases by 4. And that's because of this squared in here. So if you double the velocity, you get 4 times as much kinetic energy because 2 squared is 4. Okay? So that means the brakes have to do 4 times as much work to stop the car. So the brakes have to do 4 times as much work to stop the car. Work done is force times distance, so if they have to do 4 times as much work, then the distance increases by 4. Okay, 4 marks available there. Question 2. A skydiver steps out of an aeroplane after 10 seconds. She's falling at a steady speed of 50 meters per second. After another 5 seconds she opens her parachute, and then after another 5 seconds she's falling at a steady speed. This speed is now 10 meters per second. Calculate the acceleration. So acceleration is change in velocity over time, so v minus u over t. So the v is 10, our u was 50, and our time was 5. So we're going to get minus 8. If you get 8, it doesn't matter, but the answer should be minus 8 because she's slowed down, okay? 3 marks available for that. So you get a mark for writing that, and a mark for putting the numbers in, and a mark for the answer. It doesn't matter if it's negative or not. Then, why the skydiver eventually reaches a steady speed with or without her parachute. So initially they'll accelerate due to gravity. Okay, as their velocity increases, the drag increases, or the air resistance increases, and then eventually the weight equals the air resistance, so a constant velocity is achieved. So 1 mark for saying it accelerates due to gravity initially, 1 mark for saying as the speed increases the air resistance increases, and a mark for saying they eventually equal each other. Explain why the skydiver's steady speed is lower when the parachute opens. Basically it's because there was a big air resistance. So the big air resistance slowed them down. It says the skydiver and her equipment have a total mass of 75 kilograms. Calculate the gravitational force acting on this mass. Okay, so we've figured out our acceleration on here. So we've got mass and acceleration. So we're going to use F equals ma. So F equals ma. So 75 times minus 8, which equals minus 600 newtons. Doesn't matter if you've got the minus or not, okay? Doesn't matter if you've got the minus or not, for 1 mark. Right, those are the answers to that. Hopefully you've understood them and feel okay about them.